Well, welcome to our very special video cast here at the Virgin Active in Cape Town. My name is Mike Finch. I'm the co-host of the Science of Sport podcast. And on my left-hand side, I have the scientific advisor for Virgin Active, Professor Ross Tucker. He's also my co-host on the Science of Sport podcast. And a very special guest with us today, Professor Linda Gail Bekker, who is the Professor of Medicine and the Director of the Desmond Tutu HIV Centre. And most importantly, and this is why we're talking to you today, you're a clinical trialist. So maybe, Linda, you could start off by talking to us a little bit about what a clinical trialist is.
So when innovation, new vaccines, new medicines are moving into being used, they have to go through human clinical trials. And I have over many years developed the expertise to be able to do that safely and ethically. And we've been very involved in testing the COVID vaccines recently as a result. So I think that's why I'm here today.
Well, we're going to talk obviously very specifically about the COVID vaccine and your involvement in that. Let's just look back on your career. You've obviously got a very illustrious career in this sort of space. You were born in Zimbabwe. You were initially going to get into geriatrics, but then you got involved in the HIV side of things. Why did that shift for you as a medical person?
Well, I trained at UCT, but had to pay back a bursary, so I had to go up to northern KwaZulu-Natal to do that, and found myself working up in the grammar doulas up there, just as the HIV epidemic was really hitting in South Africa. And working in the wards there, recognizing young people coming in droves and dying of this really mysterious disease, and feeling incredibly frustrated because I'd just finished medical school and not actually being able to help those individuals. Recognized I needed to know more, and so went back to medical school to specialize, got into infectious diseases, then recognized that actually my heart is in finding answers to solutions, so I am today a medical researcher. And that, in infectious diseases, and that's been just an amazing roller coaster ride. We're in the epicenter of the HIV epidemic here, so it's been amazing.
And also, in 2009, you were given the Royal Society Pfizer Award for research in tuberculosis epidemiology. So that was also a factor in what you were doing beyond HIV, also tuberculosis, which is obviously a big issue in South Africa as well.
Correct. Those two, it's they're the dual trouble in that the two talk to each other very much. We have, sadly, in this country, the infamy of having the biggest HIV epidemic in the world, but we also, people don't know, we have an enormous tuberculosis problem. And the two go hand in hand, and so, it's been natural to work on both. So the Desmond Tutu HIV Centre was born. I'm married to a tuberculosis researcher, and so, there are the many partnerships underway there.
What's interesting is that when you look at your background, obviously you've specialised in certain areas. Now, just tell us when you first got wind of this COVID problem that was coming your way. When did you first realise that this potentially is going to be something that's going to change the world?
Yeah, well, my whole life we've battled pathogens, right? So the enemy is the virus, the bacteria, the thing that invades humanity and has to be battled. And of course, when this new virus came along called SARS-CoV-2, we all pricked up our ears, fascinated, I guess, by the physiology, the science, the biology, but very quickly came to realize that this was deep trouble for the world.
Can you remember the date that was? Like what month?
Yeah, I mean,
what day of the week?
we start. I'm not sure, it's not quite a JFK moment in that sense, but definitely, in January, realizing, hold on, this is problematic. I think people will remember that maybe we weren't getting quite the news from China that perhaps we should have, but there were incredibly courageous doctors who were speaking out, and for me was the one particular Chinese doctor who subsequently succumbed to COVID, but came out live and said, here's a problem, and that was, I think, the wake-up moment that this was a problem, and it was going to become a problem around the world. And then we just saw the thing take off. And I guess we, here in South Africa, in the Southern Hemisphere, there was both a problem of, maybe we'll get by, and then the huge anxiety that we have 8 million people in this country living with HIV, many people battling tuberculosis. Were we going to see a much worse situation? It hasn't panned out completely like that, and we're very grateful that we haven't been hit harder, but we've been hit as hard, I think, as anywhere else in the world, and that's why, all of us in the HIV and TB world have pivoted to say, what could we do about COVID? Rightly, because this was the new emergency in the country at the time, and it's been almost natural that we take on this new pathogen.
Russell, I'm just going to bring you in here. One of the interesting things about the space that people that are watching this video cast are in is that a lot of people watching this are very active and healthy and live healthy lives and eat well. Where do you think it sits when you sit with a pandemic like this? Do you think people are kind of, well, I'm okay, I'm fit and I'm healthy? Or is that a misguided belief that people have when they sit in a healthy space in their lives where they think is healthy?
Well, they have that belief, and that's part of the problem. My recollection of it is it was about a year ago to the day almost that I think South Africa had its first case, because I remember flying back on about the 23rd of Feb from overseas, and that was when they just started scanning people at the airports. And then I recall we had a couple of people come in from Italy with cases. So they would have when it landed on our own doorstep. And I remember very quickly it diverged because people were trying to understand what was happening with this disease, and it very quickly became portrayed as only the old and the vulnerable will succumb. And I think that was where partly the message got lost, because subsequently we've discovered, they knew there was asymptomatic spread, but they didn't realize the extent of it. And they realize now, for instance, the long COVID, where you need not necessarily die, but you will have this burden of disease potentially for years, and the things that will do to society. So I think that the messaging early on was very confused because it was novel. How could you know what was going to happen? And the young, healthy populations might have thought they were a little bit more invincible than has proven to be. And looking back on it now, I think it's really revealed that we're not very good at coexistence. We tend to say, how is this going to affect me? And we don't realize that we're actually plugged into a community, and the things we do for ourselves might not be the best for the community. And that's shown up pretty starkly by COVID.
Well, yeah, let's get drilled down to basics here. I think for most of us, we kind of know what a vaccine, the first vaccines were like in 1798 for smallpox. How does a vaccine work, very simplistically?
So vaccines are phenomenal. Jenner, who, first discovered it, what he did was he took the disease itself and sort of scratched the skin and inserted a small bit of the disease. Obviously, we would never do that today. We'd need to be very careful with something like HIV or SARS-CoV. So what now happens is we identify on the pathogen a part of the pathogen.
Just explain what a pathogen is.
The pathogen is the microbe,
that's the bad guy.
The bad guy.
Right.
So we find something on the bad guy, usually on its surface, that is highly immunogenic. So what that means is we know when it gets into the human host as wild infection, real infection, it causes the immune system to go, into red alert. So we want to identify what that the red flag is, if you like. We then find a way to transmit just that red flag into the body. Now, there are a number of platforms we can use to do that. You've heard of Moderna and Pfizer. They use a little bit of RNA to do that. So that's a little bit of our genetic material. It can't replicate, it can't do anything. It's merely a vehicle which allows that red flag to get into the body. Johnson&Johnson uses another...
The RNA from the virus?
Yeah.
Okay.
Johnson&Johnson uses another virus, so a virus that causes a common disease like common cold. It uses Ad26. It causes very mild disease in humans, and it's been cleverly in the lab had its battery taken out, if I can use that analogy. So you now have a vehicle to bring it in that doesn't have its battery, but it becomes a vehicle to bring the red flag into the body. And creates the immune system's excitement and then primes the immune system. So the human frame thinks it's getting infection. It's not, but it gets primed. Then, should you encounter the infection down the road, that immune system is ready to roll, because our immune systems need a bit of time. The reason why people are able to overcome SARS-CoV-2 is usually their immune system kicks in and overcomes the disease. For the few that succumb, that get very sick or die, the immune system doesn't kick in time. So what we're doing is we're giving the immune system a little bit of a leg up so that it can get going. And so when the virus invades, should it do so, the immune system is primed and ready to roll. That's all a vaccine does. So it's highly natural. It's not a pharmaceutical in that regard. And it really is using the immune system to do the work.
I think people kind of, people get fearful of it because they think we're actually putting some of of this disease in me. So the perception is, well, maybe it will, suddenly become the disease. I suppose it's difficult for people to understand how to educate people correctly.
So here's what I often use with the lay public, if I may, is, if you took that front bit of a Mercedes-Benz, that iconic, or I don't know, Maserati or whatever, the badge, and you gave that to somebody, you would say, what does that look like? They would say, oh, that's that vehicle. Can that vehicle drive? No, but it's that vehicle. And so it's exactly the same. You're putting a part of it in where the human body goes, I recognize that thing, I'm going to respond. But that thing can't drive on its own.
That's a great analogy. I love it. As an analogy expert.
I was going to say, Ross, you're an analogy expert.
That's a really good analogy.
I mean, if you look about how when we talk to people that we know within our communities and the people that we ride bikes with and run with, I think most people understand the basics of that. But there is still people that I know that I would consider very educated that still think that there is some sort of repercussion of the virus of the vaccine not working, and therefore be careful of it. So let's see what happens.
I think vaccines have had bad press, so there was people may have heard of the MMR kind of debacle. Unfortunately, that was written up in a prestigious journal that MMR in some way was related to autism. And that has been debunked. The journal has retracted. The guy who put that out there has fallen on his sword. There's been a lot of debunking, but unfortunately, often propaganda sits and creates its own conspiracy. So I think vaccines have had a bad rap in the past. I think what the public need to know, we deploy millions of vaccines. I remind a lot of people we don't get a lot of serious childhood illnesses because of vaccines, and yet we see those early pediatric immunization programs as kind of just normal and natural now. Those are all vaccines, right?
Same way that the COVID one's going to work.
Exactly. And, we go through that process. We make sure our own children go through that. Those are vaccines.
Yeah, you see it occasionally when a country or a region either refuses or can't administer vaccines. And then all of a sudden there's a resurgence of a disease that the world had forgotten about. So I think it was 2 years ago in the Pacific Islands, Samoa, Fiji, those places had a resurgence of measles. A number of children died because there'd been enough people say, we don't want this vaccine. And then it becomes a problem. And people's memories are short. Edward Jenner with smallpox, that was killing millions.
Yeah.
It no longer exists. Why?
Well, and Ross, polio. You used to walk into those hospitals and all these people on iron lungs. That's gone. Where's it gone? Well, it's gone because of Salk and Sabin. We have 2 vaccines that are incredibly powerful that have effectively eradicated polio around the world. So you don't see people in calipers anymore because that disease is gone.
Just explain what's interesting for me, and this is maybe a slightly technical question, is that, for instance, children who have a chickenpox vaccine need 2 vaccines of those. Some vaccines don't need 1. In the case of the COVID vaccines, some of them require 2 doses. The J&J one requires 1. Why is there changes in the dosages for some of the vaccines and not others?
Yeah, I think it's about the kind of vaccine and how it works. So in HIV, we've tried all manner of, and we haven't had success. So there, it's about the microbe, the actual bad guy. that bad guy is incredibly complicated, and we're struggling to find the red flag. So we haven't found the key. Now, we were lucky with SARS-CoV-2 that it has a red flag called the spike that is like sticking out, and
Everybody
the obvious thing.
We all know what it looks
Everybody
like.
knew that it had to go for that.
That's
and
the badge on the car.
And it worked beautifully, right? So we have these vaccines we now have today. But, that sometimes we need to prime the immune system and then we need to boost it. So people will know they have to go for tetanus jabs every few years. When you, as an adult, if you get involved in a car accident and you rock up at the emergency downstairs, the first thing you're going to get is a tetanus jab. Now, what is that? That's a boost. That is, you were primed as a child with tetanus vaccine, but we know that the durability of that vaccine, its ability to keep the immune system awake and alive, is limited. So we boost it at regular intervals to shake up the immune system again. And that's so you'll know AstraZeneca is a 2-dose. So prime and boost. That gives the immune system another jolt. If you like, it's kind of, zzz, and get it going again. So as it happens with Johnson&Johnson, the weighing up was 1 dose is good. Maybe 2 doses will give the immune system a better chance, but then you have a logistical nightmare of having to find the person for the second dose. So they weighed up the risk and benefit and decided they'd go with their prime only. They actually do have a trial underway at the moment to see what's the added value of the boost. If the added value outweighs the downside of having 2 doses, then they'll have that as an option.
And this is, by the way, the big discussion in the countries using Moderna and Pfizer is because of the limitation in supply, can they get away with 1 single shot? And can we delay? Because it was meant to be 2 weeks apart, I think, or 3, depending which one it was.
3 to 4 weeks, depending.
They're saying, can we push that out to 12 weeks? Because that way they can vaccinate 100 million instead of 50.
And come back to the 100 million later,
right.
Which,
That's a really interesting scientific and ethical question. Because if the clinical trials did 2 and you decide to do 1, then you're not obeying your own clinical trial data. So that's a massive debate they're having. The Johnson & Johnson vaccine almost makes it moot.
Yeah, and I think, that's been with their hat on, which is a global outlook. They've decided right from the get-go, let's put our money on the single dose, see how that goes, whereas other manufacturers came in with the 2-dose, now having to reduce and figure out what the impact is. They did it the other way around, which, I think it's because they have a global outlook, and we know in our areas it's just much easier to give a single dose.
And is there not, I've read about this and obviously I need to check it out with you, the temperature of which some of the vaccines have to be kept at versus the Johnson & Johnson one is also critical. Some of them have to be kept at like -70, whereas the Johnson & Johnson one can be kept in a normal fridge.
It just puts a level of logistical nightmare.
That is true.
Absolutely.
Yeah.
If a -70 fridge, we have them in all our pharmacies.
So it is
in our
-70, is it?
It's -70. Yeah. That is, it's a really expensive fridge. You don't buy them at the supermarket, right? And so having a little clinic in Pofadder with a -70 is not going to happen, right? That's going to be really difficult to do. Whereas, something like the Johnson & Johnson, you transport it at 2 to 8, but once you've got it in the syringe, you can put it in the fridge for 6 hours. Once you thaw it, you have a bit more lead time, so you can then deploy, and you can just use a normal kitchen fridge to store it, which makes it just so much easier.
And think about how that amplifies the capacity to deliver it. Because now, as Linda Gail says, everyone can do it. And that was because Pfizer and Moderna were mRNA, which is so unstable, whereas the Johnson & Johnson's a DNA, and it's inside that adenovirus, and it's just a much more stable product. So
the RNA viruses are very interesting. That what is very exciting about them, and maybe that's the topic, to move on to, is the variant. So what's happening with this pathogen? And it, we should never underestimate the microbe, the bad guy. The bad guy can be badder than we thought, right? So I think we've come to recognize that now with SARS-CoV-2. The nice thing about the RNA vaccines are they're quite amenable to being tweaked. So they're quite adaptable to changing the red flag on them at will. And so that may play out as quite an important asset, depending on how often the bad guy changes its colors.
So one of the interesting things about the J&J vaccine is that the variants are potentially better controlled than some of the other versions of the vaccine. Just explain how that works.
Yeah, so I think some of this is serendipity in the development of the vaccine. So let me back up a little bit to say the SARS-CoV-2 is an RNA virus, so it's the kind of pathogen it is. Now, viruses are incredibly interesting microbes in that they don't carry a lot of baggage. They are dependent on jumping into human host cells, hijacking that cell and replicating themselves. Now, because they don't carry a lot of baggage with them, if I can put it that way, they're not very good at fixing when mistakes happen in their own genetic makeup. Now, we all have mistakes in our genetic makeup all the time, any living organism. But we as humans fix it a lot. We've got a lot of machinery that fixes mistakes in our genetic material. The virus travels light, it doesn't, and those mistakes stick. Now, every now and then, a mistake is good for it. It increases its survival chances. And we now call those mutations or variants. So when the virus undergoes a change or a mutation that favors its survival, that will continue. It's a Darwinian principle. It will just stay, survival of the fittest. And what we found very quickly, as you know, from about October here in this country, there was a switch in the virus that made it more transmissible. So it got more catchy. It could go from human to human more quickly. That obviously was a survival tactic, gave it a leg up. And so it stuck. And that was a big change. It potentially changed a little bit of the red flag, if you like, created a bit of a pink variation to it. And it turns out that some of the vaccines, well, in fact, all of the vaccines that had been made to the prototype virus, the one that came out of China the first time and was in our first wave, now created some resistance to those vaccines in the second wave. So this new variant that is being described. And that really was what drove our second wave. Because we were conducting a couple of trials here in this country, namely AstraZeneca and Johnson&Johnson, we actually know how those vaccines performed against our new variant. So we have that information. We just don't have that information for Moderna or Pfizer or Sinopharm or any of the other vaccines, because we did not conduct it on the ground here when we had that variant moving. So what I can tell you today is because the trial was conducted here in South Africa, we know that AstraZeneca appears not to have been able to perform as well, and that's why government has put it on hold. And J&J, it took a hit in terms of its overall efficacy. But as Ross was saying earlier, importantly, we know today that it did not make any difference to its ability to reduce severe disease resulting in hospitalization or death. So that was an 85% reduction in severe disease and death in Brazil, in America, and here in South Africa. And we know most, if not all, the infection that occurred in that trial in the placebo arm of Johnson&Johnson in the sham arm was with the variant virus. So long and short of it is, this SARS-CoV-2 is changeable. We will have to see down the line what that changing nature has in terms of vaccine manufacture and development down the pike. But what we know today is Johnson&Johnson has a little bit of a reduction overall, but the thing that matters is keeping people out of hospitals. It seems to be as effective in that regard. So, good news.
And the thing that frustrates me while we're on that subject is when I read the media reports, I see them bury the biggest benefit, and they focus instead on reduced efficacy. But you must understand from those clinical trials that when they talk about efficacy, they're talking about, does the person develop any symptoms at all? In other words, headaches, fever, chills, cough, loss of smell, maybe. By far the most important thing is, does it prevent hospitalizations and deaths? And all the vaccines have been miraculously effective in that regard. I mean, this Johnson&Johnson one is 100%. So 1,000 people will get exposed to this virus and none will die or who need hospitalization. That's a miracle. That should be the headline. It's really frustrating when you read an article and it's 20 paragraphs long and that's mentioned once, and the other 19 talk about the variants and how it's escaping the vaccine. That should not be the key message. The reporting on these vaccines should be 100, 66.
Right.
Not 66,
Yeah.
100.
Yeah.
That's the headline.
It's true, I never really understood that.
And I mean, if you think about it, so what does it mean for the South Africans? Well, if we get people vaccinated so that you can travel, so that you can go back to life, you might, for a day or two, have a SARS-CoV-2 infection so that, you feel a bit out, you might even have to go to bed for half a day. But are you going to end up in hospital on a ventilator? No. And that's going to be critical, right? I mean, that at the end of the day is what has been devastating, is seeing our hospitals full with individuals, not knowing who, next. That's been the part of the COVID pandemic that has been incredible. And then, of course, our efforts to keep people out of hospital, all the lockdown and the restrictions, that's what's impacted our lives the most.
Right. And we've got friends and colleagues, educated people, who say they don't think they'll bother with the vaccine because it doesn't work, because they've read those headlines saying 66%
So
and you'll still develop symptoms,
and Ross,
so misguided.
It'll come out. What I will say in the sort of public domain is that we also saw a reduction in the number of symptoms in individuals who received the AD26 vaccine.
Yeah.
So that's also encouraging. So if I get sick, I'm not going to be as sick as I would have been. I'm going to have maybe 1 or 2 symptoms as opposed to 4 or 5.
Right.
Yeah.
And for less long.
Yeah, correct.
So the key thing is, and I think this is one of the questions that everybody asks, this speed at which these vaccines have happened, how do we assure the public that speed hasn't been at the cost of a safety issue?
Yeah, so first of all, just to say this, 43,000 people have received this vaccine, and we did another 40,000 in the last week as part of the Sisonke program. We see reactogenicity, so people mustn't mix up your normal response to a vaccine, right? We want to feel something, because that means you're stirring up the immune system, and our immune systems make us feel feverish, maybe have a few chills, maybe feel a bit flu-y, right? That's what
might happen when you have the vaccine.
And that's totally normal. In fact, you want to go high five, that means this vaccine is doing its job. So that is what we call reactogenicity.
So don't be scared when you get the vaccine if you're feeling a bit flu-y. Yeah.
Totally. As opposed to some horrible side effect. We did not see that with Johnson&Johnson. And in fact, we rarely see them with vaccines at all, by the way. It's a big fear that it's theoretical, never really plays out. And so the vaccine is safe. We can say that. The other thing I want to just say, which people may not realize, is it's on the back of an AD26. The vehicle bringing it in is an adenovirus 26. Now, that vehicle has been used for Ebola, for Zika. There are RSV. There are a number of vaccines that use that. So more than 200,000.
When you say the vehicle, when you say the vehicle, it's the transporting mechanism into the system.
So that mechanism is in hundreds of thousands of human beings with no bad effect. So that should also make people feel reassured that, it's not completely novel and new. It's using a tried and tested methodology. We actually have an HIV vaccine trial in the field in South Africa today that's also trying that particular modality. So the safety piece, I want to reassure people no corners were cut. So the time we were actually in clinical trial has not been shortened in any way. What we shortened was all the dead space in between, the time when we write the protocols, we get SAPRA's approval. Everybody moved quickly because of the urgency, to reduce that time. But the time we were in human beings was the same as it would have been under any other trial conditions. So, which is important. We went through phase 1, through phase 2, into phase 3. We know we accruing days every day in terms of how many people have got the vaccine on board and they're being followed up. The J&J trial is a 2-year trial. We will follow those individuals very carefully for 2 years. So, it's very important to make that there were no shortcuts in the actual trialing mechanism. We are watched very carefully by regulators, by ethicists, we ourselves. J&J doesn't want any bad publicity, right? And so all of that has been followed very carefully.
Well, I think in this instance, you're being watched also by the whole world.
Yeah, correct.
Because when these vaccines were made, people didn't have an expectation that 100,000 or 1 million people would get it. They knew that we're talking hundreds of millions. And if that vaccine is causing 1 in 1,000 additional deaths, I mean, there have been 250 million vaccines administered worldwide as of today. I think the United States hit 80 million the other day. So at 1 in 1,000, we're talking 80,000 deaths in the US from the vaccine. That would be picked up.
Yes.
It would be
It would make the
impossible.
news. Yeah.
And then who would be liable? The company, the big pharma, who often get accused of conspiracy theories and so on. This could not possibly be covered up. The academic institutions that verified and tested it would be culpable for ethical violation, the likes of which the world had never seen. So people need to take some reassurance from the common sense that you could not bury a dangerous vaccine on a scale of 100 million. It's not possible.
And again, Ross, we saw the media reports early when Pfizer was going, 25 people vaccinated in Norway died.
I was going to ask you about that.
Those people were, when you get into the small print,
Yeah.
they were very senior citizens in nursing homes who
right.
may well have had a life expectancy of days anyway, in terms of just being at end of life, So yes, you want to protect them against SARS-CoV-2, but it's not helpful to have a headline like that where it isn't clear what actually was achieved.
And that's where there's a degree almost of scientific literacy, and it's worth pointing out that there's a base rate in the population for death, for cardiovascular events, for strokes, for Bell's palsy was the other one that was linked as a side effect of this vaccine. But if you vaccinated 10 million people today, instantaneously, and followed them over the next 2 months, in fact, forget about vaccinating. If you just followed 10 million people over 2 months, 1,500 of them will die. 2,000 of them will have heart attacks. 50 of them will develop Bell's palsy. So now if you happen to give them a vaccine and you find that, you would be erroneously thinking it was the vaccine because it's actually an independent event. And that's why clinical trials matter, is so that you can separate randomness or independent events from cause.
I suppose it's a bit like somebody dying of a heart attack in a marathon.
Right.
And there's 30,000 people running a marathon.
Correct.
He hasn't died because he's running the marathon. He's died because he was going to die anyway.
It's just the law of big numbers. It will happen.
And as Ross says, important in the phase 3 because we do have the sham arm. So you've got the one group who don't get the vaccination randomly. They don't know. The investigators don't know. We follow the whole group. And then we check at the end the side effects in the one arm versus the other arm at the end. And we figure out, was there an unexpected higher number of those kinds of everyday events in the vaccine arm versus the sham arm? And that was not seen to be the case in any of the vaccines to date, but particularly AD26, which I have seen the data on.
Yeah, so people can take tremendous confidence in the fact that clinical trials are designed and known to do this. And so when it happens and you test 45,000 in the J&J trial, the Moderna and the Pfizer was in the 40,000s each. So we're talking hundreds and hundreds of thousands of people followed in these controlled situations, plus 250 million who've now been... If there was a problem, we'd know by now.
We'd know about it.
We'd know it.
So you're not going to grow an extra arm and you're not going to have a chip inserted into your body by the government.
Correct.
We know that.
Exactly. The needle, I promise you, because I've seen a good number of them
That's my
go
next
in.
question.
It's a tiny little needle. I don't know that you can insert a microchip through that tiny. It's 0.25 of a dose going into the intramuscular deltoid. It is the ingredient going in, and that's been tested in many, as Ross says. So no horns, no purple hair. It's going to be, it's going to cause a little bit of a flu-y feeling. Some people might have a little bit of a rash. Again, this is our own immune system responding.
Like they have,
and you know, we recommend that people take an analgesic, take something to settle the fever for a day or two.
Or a couple of Panados.
And it's never more than a day or two.
I mean, there is a small risk of an allergic reaction, which is why they try and screen people at the time, and they say, if you are susceptible to these, just hang around for 30 minutes after the shots, and we'll check that it's all okay and kosher. But they are, I mean, we're talking 1 in a million, and the upside is that you're no longer going to get COVID. And so if you simply offer people a COVID, a trade-off of the vaccine versus the virus, then you're not going to compare relative risks. It's not even a comparison.
Just explain, you touched on that in how the actual mechanism works and in the injection. There's a great footage of you actually carrying the first vaccine in South Africa where it was delivered to a nurse. Just explain your feelings or remember your feelings when you were carrying that vaccine. How did you feel in that moment?
I mean, it was exhilarating and incredibly moving at the same time. And I remind you that I've been working in HIV and TB for 30 odd years. And you know that we haven't had those kinds of breakthroughs in terms of vaccinology. And Glenda and I both just marveled because we've been doing this together, Professor Gray. And you know, the fact that a month ago we were looking at the results of the J&J and feeling so exhilarated that we saw successful results, and a month later to actually being carrying a vaccine that was going to go into colleagues' arms that would protect them, seeing that public health translation right there, actually being able to do something useful was just unbelievably, just a huge privilege and such a humbling moment, just because the power of science at that moment, it is miraculous. Ros, described it as such, and I'd be that hyperbolic and say it really felt miraculous.
I mean, the thing I think of is people think, there's a few people who worked on this. And so this little vial that I'm carrying in my little silver platter, which is the shot of Linda Gail, is the result of 10 months and 30 people's work. But that's not even close. Because like for instance, the platform was looked at in 2003. They worked out how to make the spike protein to the SARS virus. And so that intellectual capital was then invested and reinvested and reinvested and reinvested till they could make the spike protein stable, because that was one of the big barriers. Then it was a function of keeping the mRNA stable for Pfizer and Moderna and getting it into the... So by the time you're holding that thing, there are 20,000 scientists who've had 30 years worth of work. I mean, that's millions of years worth of scientific knowledge in that little vial.
What is the vial? 25 mils?
So actually the vial we're using for Sisonke carries 2 doses, and each dose is 0.25. So we have to very carefully draw up, and so we're using research pharmacists to do this, and that's why I think, again, it's a triumph that we've got to 42,000 healthcare workers literally in a couple of weeks, including, as you mentioned, the president and the health minister, which was a real privilege to ensure. But the vial needs to be carefully drawn up. It's important we give the right dose, and so we're ensuring that,
So when you say 0.25, it's 0.25 of a mil. So it's a very small little vial.
Correct. Yeah. And I think down the line again, when the company rolls out commercially, you might find like AstraZeneca contain 10 doses in a vial. So again, once you move to these big numbers, the company will make it. But we're filling this gap now with the Sisonke program. So those are kind of interim measures that we're rolling out.
Well, I mean, that's probably our final question for today. The important part about this is how it's rolled out across South Africa, the equality of it. There's obviously a lot of politics involved with this. Tell us about Sisonke and the philosophy behind the rollout.
So, viewers will know that we were all geared up to go with AstraZeneca, right? So what I didn't finish around the variant discussion is that unfortunately the trial that was done in South Africa did have variant virus in it and showed that this depleted AstraZeneca's strength as a vaccine. And I think the government took the right decision that therefore needed to be put on the shelf. And we now know that that's going to go to other countries that don't have the variant. For South Africa, we had the J&J, and that was we quickly moved to say, can we make this plan B? And I must say, kudos to national government and National Department of Health. They went, yes, let's work together. And we spoke to J&J. It's a long story. It's been told in the news. We spoke to J&J. They also went out on a limb and said, we will support you on this. So that we have moved to a 3B. It's an early access program. We have SAPRA approval for this within the context of implementation science. We are rolling out the J&J to healthcare workers because we realize that's the front line to protect. And we have 500,000 doses on promise to get that into 500,000 arms in the next 3 to 4 to 5 to 6 weeks, depending on how quickly we can do it. And also in anticipation of the J&J being licensed in this country, which we hope will follow soon now. But in the interim, this was what's sitting out there that we're worried about is a third wave, right? And so we want to be sure we get the vaccine into as many arms as we can before.
And what's the prioritization? Because obviously the health work is number one priority, and then we've seen around the world they've gone from most vulnerable to least. And so presumably we'll follow a similar pattern where elderly, and then we'll move down in age because that's where the...
So you do the mixture of who's most likely to be exposed and you really need to keep in the workplace. So that's a healthcare worker. It might also include an essential worker of some other form. Then you want to go to the most vulnerable. So even within those groups, who's older, who has comorbidities, and then work down. And yes, you're right, young people are going to be quite low in the list, unfortunately, simply because they mostly get a sniffle, some symptoms, but get over SARS-CoV-2 relatively easily.
And I've seen in the European news lately, there's discussion now around passports, vaccine passports that will allow travel and vacationing in between holidays, between countries. Do we envisage that such a thing might exist here also? And what would your views on that be? Because in your HIV work, you would have obviously encountered a lot of interesting stuff around how people are incentivized to have a vaccine. That would seem to be a gain model, but people might reject it on the basis that now they're being punished for not having it. And it's where's the balance of trying to compel people to vaccinate as opposed to ask them to do it?
Yeah. I mean, I think we don't want to compel anybody because I think that does create a whole lot of anxiety and fear right there. Why do I have to be forced to do this? And we, human beings, want to be free agents, right? But I do think that there is huge value in giving people a reason to do it. And if people, the first thing is to educate people that there's self-interest. If I have this vaccine, I'm going to survive. That's a good thing, right? But there could be other benefits and perks, like you'll be allowed on a plane and you'll be able to go to Mauritius. That would be, I think, added benefits that people could then internalize and use.
I remember the first person in England whose name I forget. I remember the second person in England to get vaccinated was William Shakespeare, and that's not a joke. But the first person was a woman, a 90-odd-year-old, and she said the best thing now is she can see her grandkids. And those are the carrots that you want people to move towards as opposed to running from the stick.
Yeah.
So it'll be interesting to see
well,
South African
and Ross,
attitude.
I mean, we were talking earlier, my colleagues, I saw them get so emotional in getting the vaccine, and I haven't been vaccinated myself, but I've seen my, good friends who are working in ICU or frontline COVID infectious disease people. They managed to get vaccinated in the last 2 weeks, and literally seeing relief in their faces, the sense of, I have this extra barrier of protection, just helps me soldier on. And these guys, remember, have gone through wave 1, wave 2. They've been at the rock face. They've seen other colleagues succumb. Unbelievable to put a vaccine into their arms,
That said, there's also a little bit of a danger here of risk compensation. And so the message around you've been vaccinated, now what? You're not instantly safe. And I think we're trying to bring the public on a journey here as well, and asking them for
maturity. I know
maturity.
we're right at the end here, but I'll tell you that within 7 days we begin to see some immunity, but we only realize full immunity at about 28 days. So, and then it goes out and counting. So people should be a little bit careful until at least a month into having their vaccination. So we ask them still to practice NPIs, right, until as many people as possible have the vaccination.
Non-pharmaceutical interventions.
Correct.
NPIs.
Correct.
I always like to translate this stuff.
Thank you.
And
Brilliant.
how long do we think, in terms of public health, the South African community, or anywhere in the world who happens to be watching this, how long do we think those NPIs will have to persist after the vaccine is rolled out?
I think the one thing I've learnt about this pathogen is make no predictions. I think we're going to have to see how often we see variations, how often we have to change the vaccine, how often we have to boost. So I think we're going to have to see how this plays out. I think it's great news that we have a vaccine to roll out, and I think that's South Africa's next big focus. Ad 26 is a good start. I'm looking forward to seeing the other vaccines come in.
Yeah. So the message is quite clear. Get out there when you get a chance to have the vaccine. Have the vaccine. There's no danger. You are going to be safe. There's freedom involved in it. There's lots of reasons why you should take the vaccine. My thanks to Professor Linda Gail Bekker and Professor Ross Tucker. That's all we have time for now, but fantastic having you guys with us, and good luck with all of your work in the next couple of months. I'm sure you're going to be pretty busy.
Thank you.